everybody, in this video I'm going to go over how to calculate none probability. So take 3 deep breaths and let's make this math easy. All right, so at the beginning of this unit, we talked about how to calculate not probability. So say, for example, you rolled a die and you wanted to find the probability of not rolling a 3. Well, the way that you could calculate this is you could just do 1 minus the probability of rolling a 3, because the probability of rolling a 3 is 1 out of 6. And if you take 100% and you minus that probability, that would equal the probability of not rolling a 3. So in this case, 1 could be rewritten as 6, 6. If you subtract 1, 6, that gives you 5, 6 for the probability. And this makes sense because there's 5 numbers that are not 3 on a dice. So this is how you calculate not probability. But none probability is basically when you are rolling a dice like multiple times. So if you roll a dice like 5 times, for example, and you want to never get a 3, even if you roll it all 5 times, that would be an example of none probability. And the way that you calculate none probability is you calculate the not probability and you multiply them together. Because this is related to the and probability idea, where if you're trying to find the probability of A and B happening, you calculate the probability of A times the probability of B given that A happens. And so you would say, okay, well, if I want to have none of my dice rolls equaling 3, then I need to have my first dice not be a 3, and my second dice not being a 3, and my third and my fourth and my fifth. And so the probability of rolling 5 dice and never getting a 3 would end up equaling 5, 6 times 5, 6 times 5, 6 times 5, 6 times 5, 6. Because the probability of not rolling a 3 the first time is 5, 6. Then the second time is also 5, 6, and so on and so forth. And so you'd multiply all of those together to find the probability of never getting a 3. So let's do another example of this. So let's say that I had these 16 packages of candy, and I'm going to blindly select 4 packages from this. If I want to find the probability of getting no candy corn, because I think candy corn is gross, then the way that I'm going to calculate this is I'm going to say, well, I have to get no candy corn the first time, and the second, and the third, and the fourth time that I select a package. And we're going to assume that we're not replacing these packages, so you're drawing them without replacement. So the way you would calculate this is you would say, well, first of all, I have to find the probability of not getting candy corn on a single selection. So the probability of not getting candy corn is going to be either 1 minus the probability of choosing candy corn, or you can just count up how many non-candy corns there are. So in this case, there's 2 M&Ms, 3 Sour Patches, and 3 Skittles. So there's 8 possible non-candy corns out of the 16 possible packages altogether. So that's the probability of getting a single package that is not candy corn. But if I want to select 4 packages and not get candy corn, then I'm going to have 8 out of 16 options for my first choice. And then for my second choice, I'll have 15 packages and 7 of them will not be candy corn. Then for my next one, I'll have 14 packages and 6 of them are not candy corn. And then I'll have 13 packages and 5 of them are not candy corn. And when I multiply all of those numbers together and divide, then that would end up equaling the probability of blindly selecting 4 packages and getting no candy corn. And when I multiply those out, the decimal that I end up with as my answer is 0.03846, etc. So it's about 3 or 4% likely that I would blindly select 4 packages and not get any candy corn. And you can also do this with percentages in large populations. So let's say, for example, in a large population, 24% of the people live in an apartment. And if you randomly select 6 people from this population, we're trying to find the probability that none of them live in an apartment. So the first thing we need to do is we need to find the probability of choosing someone who does not live in an apartment. And that's just going to be 100% minus 24%. And so that means that the percentage of people who do not live in an apartment would be 76%. And so the probability that I select 6 people and none of them live in an apartment is going to be 76 out of 100 for the first person, because there are 100% of the people in the population and 76% of them do not live in an apartment. So that's the probability that the first person does not live in an apartment. Then I have to also have the second person not live in an apartment. And that's going to be 76 out of 100. Even though I didn't replace the first person back in, because it's a large population, the percentage is not going to change very much. Because even if you take one person out of a large population, the overall size of the population is still about the same. So I would do that, and basically I'm going to multiply by 76 over 100 6 times, because every one of my 6 people have to not live in an apartment in order to have all 6 people not live in an apartment. And so I'd say, okay, well, if I do 76 times 76 times 76, one way you could calculate that more simply is by doing an exponent. So if I do 76 to the 6th power, I get this really big number, and then I'm going to divide by 100 raised to the 6th power. And when I calculate that out, the decimal that I get is 0.19269, etc. And so it's about 19% likely that I'll select 6 people where none of them live in an apartment. So that's how you calculate none probability. I hope that helps, and if you have any questions, let me know.